Alright, so here we are, section 10.5. We're going to look at something called factoring, which is basically taking a quadratic expression and breaking it down into parts that would multiply together to give us that expression. It's kind of like taking a number and figuring out what terms you would multiply together to equal that number, just at a little more difficult step here. All right, so factoring, if it is in the form of x squared plus bx plus c, meaning that we don't have a number in front of the x squared, that's based on if we got this quadratic by FOILing two binomials. If we had x plus p times x plus q, if we FOIL that, the x's times each other is going to give us x squared. And then we would do x times q and p times x in the middle, which would give us p plus q times x. And then the last two terms we'd multiply together and get p times q. So when we look at that, what we realize is the last number in this quadratic, or the c here, is made by multiplying two numbers together. And those same two numbers, if we multiply them together here, if we add those two numbers, that gives us what's in front of the x, or gives us our b term. So if we focus on that, p plus q has to equal b, and p times q has to equal c. So if we're going to factor that, then basically we're figuring out what two numbers multiply together to equal c, and then do those two numbers multiply to equal c and add up to equal b. Or so an example here, if we had x squared plus 6x plus 8, that would factor to x plus 4 times x plus 2, because 8 is made up of 4 times 2, right? So 4 times 2 equals 8, and if I add 4 plus 2, that gives me 6. So 4 and 2 add together to equal 6, multiply together to equal 8, so that's how we get that factor x plus 4 times x plus 2. So if we're going to factor x squared plus 8x plus 15, what we want to focus on is that last term, 15. And we want to come up with all the factors of 15. Now we have to be careful when we look, because when we have plus plus, if that's the order in our quadratic, then that means that we're going to factor that into two positive factors. All right, so since it's plus plus, we only have to look at positive values here. So to get 15, you could have 1 times 15, or 3 times 5. If I add those together, that gives me 16. If I add 3 and 5 together, that gives me 8. And what I'm looking for is the factors of 15 that are going to add up to equal that b term, which is 8, which is right here. So those are the factors, 3 and 5. So we're going to use those two and make two binomials. That's going to be x plus 3 and x plus 5. And there's our factored form of that function, or that expression. So next one, x squared minus 9x plus 20. Looking at that last term, 20. Now, if we look here, we have a negative and a positive, so it's in the order of minus plus. And when it's minus plus, we have two negative factors. So both of our factors here we're looking at being negative. So for 20, you have -1 times -20, -2 times -10, -4 times -5. And then, so those are the factors that multiply together to equal 20. Then we look to add those together. -1 plus -20 will be -21. -2 plus -10 is -12. -4 plus -5 is -9. And what are we looking for? We're looking for -9. So that means that -4 and -5 are our factors. So x minus 4, x minus 5 is our factored form. Next one, x squared minus 8x minus 9. So we look at this, we have minus minus. And that's going to give us one positive and one negative. So one of our terms has to be positive, one of them has to be negative. So when we put those together, starting off looking at 9, or you can focus on it being -9 here. So we need one positive and one negative when we look at the factors. So we do 1 and -9, -1 and +9, and 3 and -3. We could say -3 and 3, but still going to give us the same difference here if we add them together. 1 plus -9 is -8. -1 plus 9 is +8. 3 plus -3 is 0. And we're looking for -8 there. So our factors are 1 and -9. So x plus 1, x minus 9 would be our factors for that one. Next one, D, x squared plus 3x minus 18. So here we have plus minus is our order. And so this order is also going to require one positive and one negative. Basically, if we have a negative for our subtraction for the second symbol, it's going to be one of each. If it's a positive there, it's either going to be both positive or both negative, both positive or both negative. And so then if they're both positive, then we know they're both positive. If one's negative and the next one's positive, then we know they're both negatives. So once again, if we look at this as -18, so factors that equal -18, -1 and 18, 1 and -18, 2 and -9, -2 and 9, -3 and 6, or 3 and -6. And look to see if we add them together to equal that middle term. -1 and 18 is 17. 1 and -18 is -17. 2 and -9 is -7. -2 and 9 is +7. -3 and 6 is 3. 3 and -6, -3. What are we looking for? +3, +3. Right there. So -3 and 6 would be our factors. So we get x minus 3, x plus 6. All right. And sometimes you might be going through and having a hard time figuring out how to factor a trinomial. And it's possible that a trinomial will not factor. And one way we can check to see if it factors is that we can use the discriminant and see if the discriminant is a perfect square, and if it is, then we know that that trinomial will factor. If the discriminant is not a perfect square, then it is not factorable. Now remember, the discriminant comes from the quadratic formula, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a, and that discriminant is what's underneath the radical, the b squared minus 4ac. So if we figure out what b squared minus 4ac is and it's a perfect square, we know we can factor the trinomial. If it doesn't come out to be a perfect square, we can't factor it. So for a here, the a term in front of the x squared, there's nothing there, so we assume that's a 1. B is the 6 in front of the x. C is negative 7. So plugging that into the discriminant, b squared minus 4ac. So it's going to be 6 squared minus 4 times 1 times negative 7. 6 squared is 36. Negative 4 times 1 is negative 4 times negative 7. It's going to give us positive 28. And 36 plus 28 is 64. Which, if we take the square root of that, equals 8. So 64 does have a perfect square root. So could that trinomial be factored? Yes. Because the discriminant, which is 64, has a perfect square root. Alright, so same idea with b. A is 1, nothing in front of the x squared, so we assume it's 1. B is 6. C is negative 5. Plugging it into b squared minus 4ac. So once again we have 6 squared minus 4 times 1 for the a, and times c, which is negative 5. 36. Negative 4 times negative 5. It's going to be positive 20. It's going to give us 56. And if we check the square root of 56, that's going to come out to be something like 7.48 and a bunch of 3's. And so that is not a perfect square because it didn't come out as a whole number. So by that one we would say no, we can't factor those. So that is section 10.5.